I couldn't tell because I thought I saw a shelf in the upper right corner. It's like, is this
Yeah.
real?
So yeah,
All right,
but my
we're about
bookshelves
to
are
be
they're
live.
a mess.
And we should be live.
Have we collapsed the wave function yet?
Yeah. Well, we always have to wait for somebody on the chat to actually tell us that we exist. So that is not for us to decide. Can the wave function collapse itself? Only if it's a Boltzmann brain, I think. That was a really nerdy joke. All right. Cool. All right. So you know how this works, everybody? Definitely say hello. And then I'll try to say hello in the chat. And it just to warn you all, it's been like 2 weeks since I've done the Weekly Space Hangout, and I've got a whole new monitor set up, which is better, but it's not configured nicely for this. So before I was like looking all the way around at all these monitors, and now I've just got like one monitor that I'm closer to. So hopefully I won't be craning my neck in all directions.
What's monitor size?
42.
Curved?
Yeah, and no, it's not curved. It's a nice monitor. I was spending so much time on these old crappy monitors that I just sort of connected all together onto this. I had this sort of octopus arm that was for putting 4 monitors towards me that I'd bought like 8 years ago. So
I've always figured you had a 6-monitor setup or something, just the way I've seen you look.
I mean,
around.
I assumed
Yeah.
at least 4. So
Yeah,
not,
it was 4.
Not
yeah.
surprise me.
Yeah.
I'm staring at a laptop and 2 smartphones. So
Yeah.
I have a laptop and a brand new big monitor behind it, so
Yeah,
I can actually. I have the same thing. I have a new configuration, new desk. I'm still trying to figure everything out.
So I got to show everybody something that arrived in the mail today. Hold on, I'll be back in 1 second.
Talk amongst ourselves, right? That's how this works now.
I'm talking about what arrived in the mail to me. It's a COVID test. Apparently, our university is now insisting that we take all COVID tests before we come back to the university.
Oh, interesting.
Any guesses what
Yeah,
this is?
you have to do it in front of it.
What?
That looks
are
like
we-
a target.
Is that the monitor box?
Oh, okay. SpaceX. Oh, you got the Starlink.
Oh,
You've
you
the-
got your
the beta test.
beta Starlink.
I signed up for that. They haven't sent me one.
Yeah.
Yeah, they're in beta testing now. So
Yeah.
Yeah, and the speeds are blinding from what I've read.
interesting.
Yeah, we've had horrible storms here it came about a week ago, and we've had just awful storms. Every day my phone is freaking out about wind warnings. And so I'm not going to go and try and set it up and deal with that in the wind warning. So
that box looks a little big for me to backpack in Morocco with, though.
well, and they say in the user agreement that it's only for the place, for the address that you sign it up at. But
okay,
that
that kind of
seems-
defeats the purpose.
it totally does. I want to take that thing in the car and go camping.
Exactly.
You know, hike with it.
I go a lot of places with questionable internet. That's what I would like to use it for.
Yeah, exactly. So I think it's worth it. I think maybe I'll do an unboxing, on Open Space or something, and we'll take a look at what it actually looks like, and I'll set it up. But yeah,
Be wary of the haters. Just well, you know.
well, I nicely am able to go both sides of that fence. I can,
Yeah.
I actually think Starlink should only be used to access remote observatories and to share astrophotography. That's its only legitimate use is for that.
Yeah.
Okay, maybe watching, television when you're at the cabin. All right. I'm going to say hi to a bunch of people. Hello to Andrew Planet, Andy Cowley, Ben Kalo, Bob Moeller, Brant Portner, Corey S., David Dunn, G. Grindle, Greg Nickel, Hal McKinney, Horizon Brave, John Suffield, Johnny J., Johnny Zed, Larry King, Nancy Graziano, Noel Ruppenthal, Raj Luthra, Rob Fowler, Summit Tandon, Susan Hunter, Tree Farm, Trey Harmon, and Zach Perry. Hey, everybody. Welcome to the Weekly Space Hangout. I hope you are all having the best possible 2021 so far. It's a weird day, but we'll get through it.
Eventful day.
Eventful.
It was an eventful day, yeah.
A very hard time to pay attention and write day. I will say that.
Yeah,
Yes.
I'm not gonna lie, I was just doing a lot of doom scrolling.
Yeah, I was trying to write the script for tomorrow, and it's a yeah.
Yeah. Yeah. So if anyone, decided that they weren't going to do work today, I think it's perfectly reasonable. All right. I think we've hit more than the 5-minute mark, so let's get into the show. I'll put you all back in your boxes. There we go. All right. You can see that there's like a little window popped up there. That's part of the problem here. Okay. Let's see. Okay, great. Over to me. Man, I should remember how to do my job. Okay. And get my script. All right, here we go. I'll put in front. Hello and welcome to the Weekly Space Hangout for Wednesday, January 6th, 2021. Ha! In your face, 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about the first detection of a built-in wobble on another planet. Japan planning to launch a wooden satellite. Astronomers improve their distance scale for the universe, but it doesn't resolve the crisis in cosmology. Joining me today, we've got a full crew. So we got Michael Roderick. Hey, Michael. Welcome back.
Hello. Thank you for having me.
We've got Dave Dickinson. Hey, David.
Hey, quarantine year 2. 1 year's worth of quarantine here. So
Yeah, exactly. Yeah, it's all
still
coming
not
together.
bored yet, though.
No,
Still not bored.
I definitely finding things to keep me entertained. And we've got Beth Johnson. Hey, Beth.
Fraser, how's it going?
Good. Nice Mars. It's a hint.
you.
It's
Thank
a
you. I
hint
love-
of the story that's yet to come. All right. Now, before we get into our extra special guest this week, I want to give a huge, gigantic shout out to our good friends at the Weekly Space Hangout crew. They are our producers, executive producers, directors. Really, they just call all the shots. We are just their puppets to be able to bring you the space news. So if you want to be a part of this community, go to wshcrew.space. They'll give you your executive producer credentials so that you can reach out to amazing guests. And speaking of amazing guests, we've got one of my favorites this week. We've got Dr. Alan Stern, principal investigator of New Horizons and literally everything else. Alan, welcome back to the Weekly Space Hangout.
It's good to be back, Fraser.
So how's it going?
It's going good. It's going busy. I'm involved in half a dozen different space missions and a new NASA proposal. So
let's just run down. Let's get an update on New Horizons. How's New Horizons doing?
Man, it could not be doing better. The spacecraft is in perfect health, and we're lucky that NASA finished their upgrade of the Canberra DSN station, the big tracking station down in Australia, because that's the one we use the most. And it's been offline for a year. Now it's come back online so we can communicate our data back to Earth much more efficiently.
But at the distance, it's got to be still a trickle.
It's about 1,000 bits per second.
Yeah.
If we turn on both transmitters, we can double that. We have two transmitters the same frequency, but opposite polarizations. And DSN can receive them both at the same time. That's still pretty slow compared to any internet.
Yeah.
But it works. And we're putting new software up on the spacecraft this summer that'll allow us to do a lot of data compression that we weren't able to do before, so that we can do a lot more science per year, because the bottleneck of getting data to the ground is going to be largely relieved. Our data rates won't go up, but the net amount of science that comes to the ground is going to go up dramatically.
And everyone involved on the team, all of the planetary scientists are still crunching the data. I've seen some reports coming out about New Horizons contributing to studies of the heliosphere, things like that. What new science can we hope to see coming from New Horizons over the next?
Yeah, well, first, it's a coincidence, but today we had a set of 24 research papers from the Pluto system and the Kuiper Belt, including the Arrokoth flyby, that came out in the planetary science journal Icarus as a special issue. So that represents something like 250 separate workers, authors on these papers, doing all kinds of data analysis from these flybys and from the astronomy that we do between flybys in the Kuiper Belt. But we're looking forward to a lot of new stuff as we go farther and farther into the heliosphere, which you mentioned. We have instruments that are just so far advanced compared to Voyager because they were built in the 2000s, not back in the 70s. That we can do just amazing things scientifically. I can get into details if you're interested. We're looking for a new flyby target. That would be our last. We only have a little bit of fuel, about 1/8 of a tank left.
I was just going to ask you about that, Alan, actually.
Yeah.
Yeah, and I haven't spotted any gas stations in the Kuiper Belt just yet.
So there's no potential timeline as far as when we might hear about a third target, or?
Well, first I should tell you that with this small amount of fuel, the odds are probably against us. But the odds were against us to find Arrokoth. And Dave, if you remember, it took us 4 years.
Yep.
We did 4 years in a row before we found the needle in the haystack. We just finished our first year of searching using primarily the SoFIA Telescope, which is one of the largest in the world. It's on Mauna Kea in Hawaii. And they have the best wide field camera for our purposes. So we formed a collaboration with the director of Subaru, and 11 Japanese scientists joined our team. And we've been getting tremendous service, a lot of observing time. And we've spotted many new Kuiper Belt objects, close to 100. These are all discovered from in the Kuiper Belt.
Yeah.
I'm sorry, these are all discovered from Hawaii, but then we observe them from within the Kuiper Belt. And we just finished 3 days ago our first set of observations of the new Subaru targets.
So New Horizons is confirming discoveries made by Subaru?
No, we confirm them on the ground.
Right. Okay.
Hubble, then we get the Hubble to help us refine the orbits so that we can point the telescopes on New Horizons. And from our closer range, we can observe things that no one on the Earth or from the Hubble or even from the James Webb could do. And we can also measure the objects from different angles than you can measure from the Earth.
Right.
And gives us strong insights into the properties of their surfaces, how fluffy they are, how dark they are, some other properties as well. And this is completely unique science. You need a spacecraft in the Kuiper Belt to do this, and we're the only one that's there and the only one that's planned for the foreseeable future.
Now you've got, you're scanning the sky, and of course we've got Vera Rubin coming online next year. Hopefully that'll help with the search as well. And I mean, obviously you'll take at this point any target that's within your fuel cone, but if you could really win the lottery, what kind of an object would you love to be able to pass next that could be like the polar opposite of what you've already observed in the Kuiper Belt?
Well, you're right, Fraser. No Kuiper Belt object is a bad Kuiper Belt object for science. But our spacecraft is speeding along at the rate of about a little over 3 astronomical units per year. And the Kuiper Belt is made up of a whole series of different, kind of a melange of different populations. Some of them, like Arrokoth, what are called the cold classicals, formed right there in the Kuiper Belt. Others were injected into the Kuiper Belt when the giant planets scattered everything out and cleared out the middle solar system. And so we're guaranteed by the fact that we're farther and farther and farther to see an object in a different population than Arrokoth if we get another flyby.
Which was in a different population from Pluto.
That's right. Pluto is one of the resonant objects in the Kuiper Belt that were actually formed quite a bit closer to the sun, maybe as close as Uranus is now, and then were transported outward with the migration of Uranus and Neptune. Whereas Arrokoth is sort of a bedrock sample formed there. And then the scattered disk objects, the ones that are becoming more populous now that we're farther out, are a whole nother breed of cat.
Yeah. So it's almost like any object will be, so there isn't like some, I don't know, like when I sort of imagine the asteroid belt and there are all these different carbonaceous chondrites and there's and to be able to make a flyby on a metal asteroid like Lucy would be incredible. Or sort of like Psyche. And so I think, if there's some kind of, I don't know, rare type out there, rare Pokemon out there that you could fly by.
Right. If I had a big enough gas tank and we could get a choice of several, then we would optimize it.
Yeah.
But in our case, we're going to have to get lucky before we leave the Kuiper Belt in the late 20s to find another flyby target. One of the surprising things, though, that we found in our Subaru searches this summer were Kuiper Belt objects that we passed closest to in 2024 and 2025. And that surprised us.
Interesting.
We shouldn't be detecting objects that we would fly relatively close to that far out yet. And so that's maybe telling us that there's an extension to the Kuiper Belt. Or a second belt beyond.
You must be, Alan, against that, looking at that very star-dense region toward the Milky Way, because I know Pluto and New Horizons are heading off toward like Sagittarius and Ophiuchus. That's a very hard region to parse out targets, probably.
The needle in a haystack, probably. Exactly right, Dave, because we're looking in the hardest part of the sky for background confusion. And when if you ever see one of those images that we get from Subaru, it's just obliterated with stars.
Yeah.
So we have to model all of that and subtract the stars away to find the little faint embers of Kuiper Belt objects. I will say, to the people that do that on our team, they are virtuosos. I don't think they're any better in the world.
That's incredible. So let's talk about some of the other missions that you're working on right now.
Yeah, well, one of them is called Lucy. Lucy's getting ready to launch in October. And I'm on the science team. One of my former postdocs, who's grown up in his career to be a leading planetary scientist, Hal Levison, runs that mission. And Kathy Olkin, who's in the core team on New Horizons, is the deputy principal investigator. And that mission is going to be the first of the Jovian Trojan asteroids that we believe were formed with the resonant Kuiper Belt objects in the middle solar system. But when all that violence took place and scattered things out, it also scattered things in. And a lot of them got trapped in these Lagrange points, leading and trailing Jupiter. And so Lucy is possibly a mission to objects that could have ended up in the Kuiper Belt, but didn't.
And one thing that I found quite surprising is that there's as many objects in in Jupiter's Trojans as there in the asteroid belt. Like it's a busy place.
It's a really busy place. Absolutely. Absolutely. So another mission I'm excited about that I'm playing a small role in is Europa Clipper.
Yeah.
Which is still several years from launching, but is going to be a big flagship Cassini-class mission to really understand Europa's plumes and habitability, and to scout for landing sites for a future Europa lander.
That's going on SLS too, isn't it? That's going on SLS. It's going to be an SLS rocket mission, I think.
It's not clear.
Yeah.
There's a strong case to fly it on other launch vehicles, and there's kind of a debate going on. I don't think it's been settled. So the spacecraft is being built, and the launcher hasn't been selected yet.
Okay.
It'll just require different flybys, right? If you have to end up on a Falcon Heavy or a Blue Origin. And
it's actually a different transit time. Mm-hmm. So when we arrive, it strongly depends upon whether it's SLS or not. So, that's for other people to decide.
Yeah. But it is interesting that you're even having these arguments about what kind of a lifter to use. Tells us how much science payload is going to be on this spacecraft to be able to because we see Junos out there at Jupiter right now. We've seen other rockets, other missions make the journey. The fact that they're having a tough time finding a launcher powerful enough to make this mission in a short period of time tells us there's a lot of science packed on that mission.
It's what you're saying is true, that there's a lot of science on the mission, but the launcher choice isn't because we're having a hard time finding one. We have several good choices. It's got to do with some legislation in a NASA Authorization Act that required us to fly on SLS. Mm-hmm. But there are proponents of the other launch vehicles, and not because they like the companies, but because each has its own advantages.
Right.
And so what we end up on is probably going to get decided in the next matter of months, but it'll be decided at NASA headquarters and not by the Europa team.
Right. Yeah. Yeah. They just want to fly. Right. They don't care how they fly.
Right. And then, and I'm also involved in a series of suborbital missions, flying on Virgin Galactic to do research, to turn those space tourism vehicles into research platforms. And I just found out in October that NASA selected me to fly on one of those missions. And then my employer, Southwest Research Institute, through its internal research and development program, has funded 2 more flights. So a total of 3 suborbital space flights.
That's amazing.
Coming up in the next couple of years.
So you're going to be flying on Spaceship Two 3 times.
That's the plan.
Wow.
Or
What?
actually, the
But
plan
for
is
science,
maybe more than 3 times.
yeah. But for
three is the
science,
start.
so what is the science experiment that you're going to be testing out?
Yeah, well, I'm doing two things. One is I'm wearing a biomedical harness. This is very simple. I just turn it on before we leave, and it takes my vitals as a function of time. And rather than knowing what's happening for the pilots, this is what's happening to a researcher in space. And starting with one data set, and we hope to eventually collect hundreds over the next decade to really understand that adaptation from high G to microgravity and back to hyper G that happens so quickly on a suborbital mission. So that's the easy experiment. All I have to do is wear it.
Right.
And I've done this.
They'll be able to tell scientifically that you're having fun or freaking
Yes.
out.
You remind me of a story, and I could tell it about John Young. But no, I've worn it in F-104s and other high G fighter environments and things. And it's really very comfortable and very easy to use. It's very reliable. It's actually the same biomedical equipment that was flown on shuttle astronauts when they launched. But the main experiment for this first flight is that I'm going to be taking an experiment I developed for the space shuttle, and which flew twice on the space shuttle, and flying on Spaceship Two to look at specific targets in the sky to compare them to what we saw with the space shuttle flights to determine how good, how stable
Right.
the Spaceship Two platform is, how bad the glints, how good or bad the glints off the wings are going to be. Basically, it's a flight test of how well we can do astronomy from these commercial reusable suborbital vehicles.
Well, we've interviewed the folks with the SoFIA Telescope, and that's a tremendous observatory that flies at a high enough altitude that it can behave as an infrared observatory. So, what could you do with a 100-kilometer flight path?
Yeah, so this is flying at 100 kilometers, as you say, and SoFIA's flying down at something like less than 10 kilometers. So by being much higher in space, we have access to ultraviolet. We have access to microgravity for 10 times as long as you get on a zero-G airplane. So many processes that can't complete in a zero-G airplane parabola can complete, and they're great for flying on these kinds of suborbital vehicles. Human physiology, where we can take what used to be just small samples of a few very fit astronauts and compare them now to much more regular people flying in space in much greater numbers and get much greater statistics.
And quick turnaround times. I can imagine you could fly a person and then fly them again, make slight changes, fly them again, iterate, as opposed to send them to the space station for 6 months.
Well, that's what's so great about this, is that it has the promise of becoming much more of regularizing space science, because the researcher can fly, just like the researcher can go in a laboratory or down to Antarctica or on an ocean-going research ship. The researcher can fly in space and do it repeatedly at low cost, so that it's more like going to the telescope than something really, truly extraordinary, like flying in space.
Yeah. It's a nice middle ground.
The 21st century is really arriving.
Ask them if they want to take any journalists on those flights to write about the experience.
Yeah, we're just asking for friends.
Yeah,
asking for friends here.
Yeah, we'll pass the names along. So the last thing I'd like to talk to you about is what comes next for Pluto. I know Pluto is always on your mind. Where are we at in the exploration of Pluto? Do you have any more missions in the works for that?
Well, first, we have a long way to go still in really understanding what the data that New Horizons collected. We're kind of now in the middle phase. With Voyager, it took a good 15 years to digest the data and to do the modeling and the really detailed integration of all the data sets from each of the major flybys. And here we are 5 years after the Pluto flyby, and we're past that triage stage where we just look at everything and go, wow, look at that, that's new.
Yeah.
Now we're doing a lot of that modeling, and that special issue of Icarus with 25 papers is a testament to that. But we have a long way to go, years more. And some of the data from the Aerokov flyby is still up on the bird and not yet down on the Earth.
Right.
And the reason for that isn't that we couldn't have sent it to Earth. It's that all these other Kuiper Belt objects that we're studying on the way have been prioritized to be higher priority.
Right.
So we should finish that up sometime next year, the Aerokov downlink. But all the while, we're passing new Kuiper Belt objects in the distance. Now, you asked what's new for Pluto. What's next for Pluto?
Yeah. What's going to take to go back?
Well, it's going to take a decadal survey because it's a very expensive mission. The next mission has to be an orbiter, not another flyby. And of course, there's a planetary decadal survey taking place right now. And missions like a Neptune orbiter and a Uranus orbiter are competing with a Pluto orbiter and many other missions in the inner solar system and to small bodies. Lots and lots of concepts, something like 100 concepts are competing for just a handful of slots. So we'll have to see how that turns out when they report out next year.
It would be tough to choose a flyby of Triton or a flyby, another flyby of Pluto, or maybe an orbiter of Pluto. I don't know.
Well, I would say that the orbiter of Pluto would be an inherently richer mission.
Right.
And there is a mission proposed to fly by Triton.
The Triton one.
More or less Pluto's twin trapped in orbit after it got captured into orbit by Neptune. But the really rockin' mission is an orbiter of Neptune that can make many flybys of Triton, not just one, and that can study all the other satellites and the ice giant Neptune itself and its magnetosphere.
Yeah.
Sort of Cassini to Neptune.
Yes, please.
Yes.
So Alan, when is your flight? When do you expect to fly?
Well, it's a little uncertain because Virgin's still in their flight test program.
Yep.
I'm hopeful that could be late next year.
Oh, that'd be amazing.
Yeah.
Well, keep us posted. Let us know. Obviously, you're going to blog the science that you do as it happens. But definitely keep us posted on all of the new stuff that you're working on. It's always great to talk to you.
Yeah, definitely.
If people want to follow you and follow your updates, where should they go?
Well, a good place is Twitter. Just Alan Stern, AlanStern. Thanks for asking. And then I have a website, alanstern.space. And you can follow me there, and I'm shortly going to be starting a blog there.
Perfect. All right. Thank you so much for joining us today. Really appreciate it, and good luck on all of those spacecraft.
Hey, thank you guys.
All right. Take care.
Bye now.
All right. Let's move on to the space science portion of the Weekly Space Hangout. I just saw a cat. Oh, I missed it. Oh, Beth just had a cat go right in front of her, and I didn't
have a tail.
I didn't get it on camera. Here we go. Here it comes. Just stand there and there goes the cat. Okay. Well, you know what, Beth, you're on my screen right now, so why don't you tell us what you got?
All right. So scientists have used measurements taken from about 2 decades worth of data from NASA's Mars Odyssey and Mars Reconnaissance Orbiters. Thank you.
Podcast listeners, the cat just went right in front of her face.
Yeah, on brand for me. So they've taken all of this 2 decades worth of data, and they have discovered that Earth is not the only planet that experiences what is known as a Chandler wobble. So this is where the pole of our planet wobbles, like when you have a top that's slowing down, and the top of the poles kind of go back and forth a little. They've now discovered that Mars does this too. So it's kind of cool. This is the first time we've really seen this in another planet to the point where we've actually measured it. So in the case of Earth, that wobble that we have is about 3 to 6 meters. And on Mars, it's 10 centimeters. So it's very small. So it's really kind of amazing that they've actually measured this down to where they have. And basically what it tells us is that the reason for the Chandler wobble is not completely well known. We do know that it involves the fact that the planet is not a perfect sphere. So because it is Earth is an oblate spheroid, it's squished a little at the middle. It doesn't wobble perfectly, so it doesn't spin perfectly. So the same thing is true of Mars, apparently, which might give us some more insight into the lower surfaces of Mars. So the mantle, it's possible that we can get some insight into that and figure out what's going on. And this wobble, like when you watch it top, it eventually slows down and kind of goes away. It's not going away on Earth, and it's not going away on Mars. And while they think they know why that happens on Earth, it has to do with ocean bottom pressure and atmospheric pressure changes. They don't know why that's happening on Mars. So there's still so much to learn about this. So it's a short story, but it's a fascinating story. So it's really kind of cool news.
Well, what are the implications of the wobble here on Earth? Like, doesn't it help? Go ahead, Dave.
It moves the equator slightly. I was going to say, outside of Quito, you can go to several places that purport to be where the equator is, and they have it marked. but it actually moves at several meters on any given decade, and it is partially due to that. I actually checked it with the GPS, and even where they had it marked was still about 10 or 20 meters off. So.
Oh, really?
Yeah. And there are several places outside of Quito and different places around the world where you go to where they say this, and the same at the South Pole. I know it wanders where the South Pole station is. They have to reset the marker because of that wobble as well.
Yeah, they actually just reset it. The 4th, I think, was when they revealed the image of the new, or it actually might have been January 1st or 2nd, where they actually revealed the image of the new South Pole marker because of the wobble.
Wow. And so if we were on Mars, we would have a South Pole marker that we would have to change from time to time as well.
Right, but on a much smaller scale, smaller scale. So it'd just be shift.
Right, yeah.
If you make the marker 10 centimeters in diameter, you don't have to move it at all, right? Just put it down.
Yeah, just make it big enough to
enclose
enclose.
somewhere
exactly.
inside the circle.
Right.
So is that what it's doing? That it's carving out a circle in the South Pole. The equator is changing slightly, but it's not like it's constantly shifting, and it's not like the entire planet is slowly rolling over.
No, it's just a constant wobble. It's on a cycle, and I think Earth's is like 400 and something years. I don't remember the exact numbers. So, but it isn't going away, which is like the weird thing, because you would think that would dampen off, and it doesn't.
And does our large moon contribute to the wobble that we have? I wonder because why hasn't the Earth's one dampened down?
I didn't see any mention of. I mean, they do talk about tides, so that could be a possibility where the tides contribute to it, and the fact that it is being pulled by the moon might have an effect too.
Right. Very cool.
And of course, earthquakes can shift that kind of thing too. And since we now know that Mars has little tiny Mars quakes, that's one of those things that there's just so many things to look into with this one, and I'm really kind of excited because it's a new place to kind of play around. There's
a story that we're working on right now that shows a landslide on Mars. Brand new, fresh landslide. I don't know if you saw this picture. It was on the High Rise blog today. And it's just amazing. Like, it's just, like, clearly it was fairly recent. It was just this straight up landslide down the side of a crater. It just shows you that Mars is still an active world. There's still interesting things going on there that are changing from day to day, year to year. There's actually another story that came out recently that I haven't covered personally, but there's a look that Mars might still be volcanically active. So they're not even ruling that out, and they're not talking about geologically recently. They're talking about recently, like in the last few thousand to 100,000 of years. So like there could be a volcano on Mars sometime in the last few thousand years. Yeah. So it's Mars is not quite the dead planet we have been led to believe. Right. Very cool. Thank you so much. All right, Michael, what do you got for us?
Yeah, so we still don't quite know what the Hubble constant is.
Yet?
So there's been a long-standing, maybe not long-standing, it's been several years, a decade or so, tension between
crisis even.
Crisis. I prefer, crisis. It's urgent. It's dangerous. So there's measurements from like the Planck telescope, which tells us that they think the Hubble constant is about 68 kilometers per second per megaparsec, whatever. And then you have measurements from SoFIA variables, which say it's actually around 73, 74, all the way down to 70. And so new measurements with HST looked at 25 new SoFIA variables, in addition to 50 which were measured before. And so now they've measured the Hubble constant to within about 1% precision, which is really good, really very precise measurements, but it's still conflicting with the Planck measurements. And just, I kind of wanted to mention how they make these observations because it's really cool. Cepheid variables are very bright. So these are stars that we can see extragalactic distances. So we use the Milky Way stars to kind of calibrate how we can observe these extragalactic Cepheids. So these stars will vary in brightness. They've got these nice little light curves, and the period of that light curve will tell you how bright it should be. But the problem is in our galaxy that's so bright, what they do, instead of just looking at it with the Hubble like a normal star, they have to actually slew the telescope as it exposes, otherwise you would completely saturate the camera. So you got these streaks of the star going through the image that they use to create these measurements. So they did that, and yeah, all the measurements come out, and we're still has some tension between CMB measurements and Cepheid, and it's kind of ironic, I guess, or coincidental that this came out now, because a month before in December, another paper came out looking again at CMB measurements, but this time with the Atacama telescope in Chile, and they measured CMB again. They confirmed Planck. So you've got two methods of finding H naught which are conflicting with each other.
Yeah, there was a paper that just came out, the press release came out today. I'm assuming the paper came out a little while ago, exactly agreeing with Planck.
Yep.
Michael, what's the current in like kilometers per megaparsec? What's the current Hubble constant now, if you know off the top of your head?
Which
one? Which highly accurate number would you like?
Best guess. I was just going to say, because both of these books, they came out in different years, have different, I'm pretty sure the constant's different based on one was 2020 and one was 2018.
So we've got 67.2 to 68.1.
That is lower than it used to be, like
from
72
from
like a few years ago.
Planck.
And the other one, using supernovae and gravitationally lensed quasars gives us 74.
71.6 to 74. Yeah.
I'll point out, though.
Look at the.
Go ahead. I was just going to say that, a few decades ago, that's like a lot more like refined than what it used to be, like within like a 50% error. Almost.
Well, the error bars used to overlap, which was very convenient, because then everybody said, oh, no problem. The error bars overlap. So obviously the right answer is in there somewhere, but it used to be this. Now it's this. So the error bars no longer overlap. They are both beautiful, exquisite measurements that disagree with each other.
I mean, I used to remember seeing textbooks that would say the age of the universe is 10 billion years old, plus or minus 5 billion.
Right.
So, this is in the 70s.
Yeah. So if you believe one, then the universe is 14.77 billion years, and or 13.77 billion years, and I don't know what the other one gives you, but.
Yeah, we're much more refined with these measurements now.
Mm-hmm. Except they don't agree.
Yeah.
And to throw in another wrench into this whole thing, there's a group from Carnegie Mellon using red giant branch stars, and they are getting 69. So they are like in the middle of this whole conflict.
But also not agreeing with the other two measurements.
Right.
Yeah.
Right. So it's really kind of indicative of the way that astronomy is, that you certainly still have some big discoveries, like the LIGO gravitational waves. That's like really big. We found something, but a lot of the stuff now is that thing we found 50 years ago. We've narrowed it down to like here, and that's what a lot of the stuff is now. It's just that nitty gritty, trying to work down the systematics and narrow down those error bars.
It is kind of amazing how exquisite. I know a lot of the astronomers are just really impressed at the quality of the work. Like in the paper that you're referencing, the cosmic distance was calibrated to a 1% precision with Gaia. Like at this point, there's not a lot of room for wiggle room. It's pretty tight.
Yeah.
So every time the crisis in cosmology comes up, I always like to sort of poll people and find out where their head is at. Where are you at with resolving the crisis in cosmology? What do you think is the answer?
It's hard to say more measurements at this point, because we have so many more measurements. Can you start to really look at the theories? Do we know, how well do we know the cosmological theories, the parameters of, they say that you need only 6 parameters to generate these cosmic microwave background models. How well do we know those 6 parameters? Are they choosing the right 6 parameters? I admit that I don't know a lot about that stuff, so that's kind of like, I'm a little more suspicious of that group, just because it's a little more complicated. But yeah, I don't know. It's tough to say.
Yeah.
What more measurements can you make now?
Right. So I guess the question then is there some, like, we either don't understand how supernovae work or Cepheid variables work. We don't understand how red branch giant stars work. we don't understand how the cosmic microwave background works, or the universe did something weird while we weren't looking. Like,
and that'd be the most interesting, right? That we don't that there's something there in the universe that we don't understand yet. That'd be cool.
That the universe changed in its expansion rate from, at some point, giving you a different rate of expansion at the beginning of the universe to what we see today. Although the numbers are so similar that it is weird as well. Like, if it was like by a factor of 10, so the universe was, then it would show, the universe is speeding up its expansion, or the universe is slowing down. But it's just kind of frustratingly close. It's fascinating. Yeah. I've mentioned this before, I think, but I love to see a really tricky problem like this just get worked out in real time in front of everybody. I think this is where science shines. And I know a lot of people, some of them who are maybe even watching the show today, they're frustrated that we have all these unknowns, but I love it. I love that we don't know the answer to these questions, and that people are working them out. And we will be there as each new discovery. It's like watching a sports ball game and seeing, the guy kick the ball in the direction of the basket. Anyway, each event is like, just adds to the excitement, and the more you know about it.
Except for a goal in astronomy takes like a couple decades to make.
Sure. Yeah. Exactly.
Not as much funding either.
It's a very slow game.
Or 100 years.
Yeah. But some of these mysteries we're joining at the end as they're getting wrapped up. Like, what is a quasar? Others we're seeing them at the very, they're still as puzzling as when they were discovered, like dark matter, or they're brand new, like dark energy. And others are just showing up very quickly, and they're getting resolved fairly quickly as well, like, say, fast radio bursts or short period, like short gamma ray bursts. So there's some, it's great to be a part of this. And that's what I find wonderful, is to just watch the narration, the narrative unfold. You're part of the story. The more you understand about all the details, like a person who really enjoys sports ball games and the players of the sports ball games, then you appreciate the advances as they come, and it's great. Fantastic. Thank you so much, Michael. All right, David, you are on my screen. What have you got for us?
Yes. Well, an interesting article I was going through the Universe Today grab bag of articles to write about this week, and I had heard of this at the end of last year about Japan's announcement. This was from Sumitomo Forestry and Kyoto University, came out via a BBC press release about trying to launch a wooden satellite. And this is in 2023. Now, this is not The Onion. This is a true story, believe it or not.
Yeah.
And it kind of had a lot of us scratching our heads as to why you would want a wooden satellite versus. And it's interesting because the way they spun it, this was from this astronaut Tokyo Doi, who was a Japanese astronaut that flew on the space shuttle. He was one of the ones involved in installing the Kibble module on the ISS. And he's at Kyoto University. And one thing that was put out there is that a lot of the news sites spun this as this would be a way to mitigate space junk.
Right.
And this, again, had a lot of us kind of scratching our heads because we're like, anything you put in orbit that's going 7 or 8 kilometers per second, whether it's wood or metal or plastic, is still going to be a hazard.
It doesn't matter, what it's made out of.
Yeah, a shard of wood and a shard of metal at that speed really... the same thing.
So, digging through some of the quotes and looking back through and researching it a bit, there was also this idea of that, wood is essentially carbon. It burns up in the atmosphere. Of course, we don't need any more carbon in the atmosphere, but it's tiny compared to what gets put out there but again, my argument with that is like, most of the hazardous stuff, remember the Russian mission Phobos Grunt that was going to go to Mars and re-entered? The big concern with that was the fuel, was the hydrazine, which is very toxic if that were to come down anywhere. And I know in Canada, I think it was back in 78, you guys had a Russian nuclear satellite that re-entered. That was a big deal.
It's still here. It's still here, and Russia won't pay the cleanup fee.
Yes. And one thing they don't show you in the movie Apollo 13 is there was also a nuclear RTG on the Aquarius module that they ditched into the Marianas Trench. Oh. That was for the ALSEP experiments that were going to be on the moon. Those were plutonium powered. They had no idea that was not supposed to come back to Earth. So when Aquarius came back with Apollo 13, when they used it as a lifeboat, like they showed in the movie, what they don't show you is NASA Mission Control had to think really fast about what are we going to do with this nuclear RTG that was supposed to stay on the moon. They opted to re-enter it over the Marianas Trench. All that is to say, anything that's made of wood is still going to have these kind of toxic materials inside it, that's going to have, so it's one thing that was brought up, and it's like, there may be an advantage with this. Wood is transparent to radio waves.
Oh, interesting.
So you would not need to have, this was pointed out, I think it was on an Ars Technica article, that you would not need to have any kind of external antennas or detectors deployed on your satellite once it launches. You could have everything internal inside the satellite. It's like your smartphone. Remember in the days we used to have a smartphone that had a little antenna that popped out, we had to pull it out back in the 90s to talk on it. Yeah. Now smartphones have an antenna that's all internal now. They've been able to miniaturize it and make it to the point that you don't need to have a little pop-out antenna on top anymore. You could have at least what they showed in the mock-up. They showed like a 6U CubeSat kind of in a wooden enclosure. You wouldn't have to have those type of, a lot of satellites fail because things deploy off to the side and then they fail to deploy and then the satellite just becomes space junk.
So how does wood behave in space?
There was an experiment back on the International Space Station on the Kibble module, and I dug this up. It was by the same Japanese astronaut to look at elasticity for it. They looked at different types of wood as far as you need something that has low thermal expansion rate because it's going to be in the sun, in the shade, in the sun again, as it's orbiting. You need something that's going to be fairly dry because all that water is going to outgas when you go into space, leaving porous, holes in the wood. If you've ever thrown like a log on a fire, you see how much water is in the wood because the first thing once you heat it up is the water all steams out of it and stuff. So it might be, they're talking about 2023. There might be an interesting niche application for this. I don't know if we're going to see anything. It was interesting. I dug back through and did some research. Has there ever been any other wood incorporated in the satellite? And I found out that NASA did on their Ranger missions to the moon have a impactor limiter that was supposed to be kind of a sort of lander if these had ever worked. A hollow wooden sphere on the tip of the impactor when the Ranger mission hit the moon was meant to kind of jettison off and hopefully come to a rest. It had a little seismic transmitter inside. Of course, most of the Rangers never even made it to the moon. They either failed on launch or they missed the moon. I think it wasn't until Ranger 6 or 7 that they actually hit the moon. And it hit the far side, unfortunately. So this transmitter, this balsa wood lander type transmitter never really functioned. Right. But I actually found some interesting pictures for the article of them holding like the basketball looking sphere. So I had never heard of this, but actually
really cool.
There was an idea to use a wooden lander impactor on the moon.
That's amazing.
In theory, it would have worked.
I think we're always surprised at how strong wood is and how it has very interesting materials benefits. I keep seeing suggestions people are trying to make other various things out of wood, surprising things out of wood.
I think it was on Mythbusters that a human bone has about the same density and tensile strength as balsa wood, actually.
Oh, so wow. Okay.
Yeah. I seem so. I remember a Mythbusters episode where they
so you could make a spacecraft out of human bone.
That's next. If we have a satellite made of bone.
Okay, all right. Nobody is holding 2021's beer now.
2021 is it's
don't give it any ideas.
Yeah. All right.
Bone sat will not become a thing.
All right, David, you've also written your year to look forward to in 2021. All the big astronomical events.
Yes.
I mean, hard to top the Grand Conjunction.
The Grand Conjunction. I was amazed that really there was a lot of public interest.
I wasn't. I feel like I had been calling it for the
It was cool.
entire year, even before that. And it was.
I had to field
wonderful.
a lot of. I had to field a lot of questions about, like, there, as you know, I had to make clear there's no real scientific, like, I've had people ask me, is Jupiter going to gravitationally lend Saturn, or is this like it's like, it's just kind of an aesthetic, kind of neat to see them in the same eyepiece.
Yeah,
and it's
a
rare.
time saver.
Yeah, it's so rare to, you know, it's really a once in a lifetime, unless, well, we probably won't live to 2081, I think is the next one, but
robot body will make it. All right, so
it's
what else?
Overcast almost every single day here, and so I still haven't really been able to see it.
Yeah,
I'm very upset.
Yeah, we're having.
I didn't see it.
I've forgotten what it's like to go outside, so I feel that.
Yeah. So what's coming this year?
Well, coming in, you know, Jupiter and Saturn are still pretty close in the dusk. I did see them earlier tonight when I was on the roof, so you can still catch them. One thing interesting with Jupiter, and this only happens about every half a decade or so, we're entering into the plane crossing for its moons, meaning that the orbits of the moons are right edge on to our line of sight. This happens twice every 11-year orbit around. So we start getting these really complex kind of events where, like tonight, there's one actually where Europa will cast its shadow back on Io, and the moons will occult and transit each other. And these are kind of, it's hard now because Jupiter is down in the dusk, so you have a very narrow window to see it. But I always thought it's interesting, and I tweeted out some simulations today, that if you're standing on Io, assuming, you know, the radiation and just everything else didn't kill you, you would actually see two solar eclipses in very rapid, within an hour succession, as Europa moved in front and back. Yeah, and I had looked at these, you know, we talk about how rare total and solar eclipses are here on Earth with the size in things. Turns out some of Jupiter's moons, like Callisto, you would see the same kind of events with, like, Ganymede being about the same size as the sun. You would see these same types of eclipses, like with the sun. They're just faster. Totality is only like 20 seconds or so.
Yeah.
But we're having a series of those this year, and once Jupiter comes back around into the morning sky, we're still going to be seeing those. I'm actually going to do a full article write-up because it's kind of nifty to, again, this is once every half decade or so you see these sorts of things. If you can catch them, they're kind of neat.
So what else we got to look forward to this year?
Also, the sun is ramping up. This is something else I want to write about too. Solar cycle 25 is starting up. Now, solar cycle 24 was very lackluster. However, there's been some talk about, with the way that it transitioned, and people that study the sun has been looking at this, that solar cycle 25 may be actually very active. We may see it. We may be in for a very active. And if the end of 2020 was any indication, we had some really big sunspots coming up. So that, unfortunately, if Artemis ramps up, it might not be a good thing. If the sun is very active, if they decide to go to the moon at the same time.
Yeah.
We also have.
I'm curious.
Oh, go ahead.
Sorry, go ahead.
No, go ahead.
So I've heard some studies about that it's actually better if you have a strong solar wind, because that solar wind blows out the galactic cosmic rays, which come in from outside of the galaxy, and so you can hide from the solar.
I know there is a
metal, but
there is a push pull. Yeah, it's
you
like
just don't
better
want to flare.
Yeah, worse.
It's
worse solar activity means the bubble is pushed out and we're not getting as much. I have seen that before.
That's interesting.
So it's one or the other, kind of. Either you're getting. But the cosmic rays are much faster and deadlier. But yeah, again, if you have a solar flare, the Apollo missions, they were very lucky that they. We have two lunar eclipses this year. One total, and this book actually still has 2021 events in it. We have a total lunar eclipse coming up May 26th, and that's for the Pacific region. So Fraser, you guys may see that. We won't see that here.
Like we'll see a partial,
Yeah, total lunar eclipses are always cool. There is a partial coming up for North America in November 19th. There is an annular coming up for the Arctic on June 10th. And
that's a road trip.
I think you'll see part of that from Canada too. We won't see it here. It'll be a partial eclipse. You won't get the annular part. And the total solar eclipse of the year is December 4th. That's down at the Antarctic. So I don't know if hopefully travel is going to be opening up. I know a lot of people had to set out the December total solar eclipse last month over South America. So it's all a matter of, I know a lot of eclipse chasers had to just set those out.
Oh.
So those are really the bigger events we're looking forward to this year. There's the
Fantastic.
usual like groups of occultations and whatnot. But.
Wonderful. Well, we've reached the end of our show. So, Dave, you're on my screen. Why don't you tell us what you're working on and where people can find out more?
Yes, I'm still writing for Sky Telescope, Universe Today. I'm also, Mike Simmons now has a new Astro Gear Today site where I'm doing gear reviews, telescope reviews, observing reviews. Yeah, it's kind of a nifty little site. And I have, of course, 2018 book with Universe Today, 2020 book, Deep Sky Field Guide. That's all out now. And as I was saying earlier, is I'm probably going to be writing about, I'm really digging into that solar cycle story. I'm kind of interested to see what's going to happen in 2021. I think we might be in for an interesting year. Yeah,
I can't wait to read that. All right. Beth.
I'm proud to share that not only is the Weekly Space Hangout coming under our CosmoQuest podcast label, but we are also now broadcast live, well, not live, but broadcast recorded on the air in Houston on actual television. So we've been spending some of the... Yeah, we're on TV now.
This is on TV?
No, okay. Daily Space and Astronomy Cast.
Astronomy Cast, that show?
Yes. Yep.
Oh, okay.
Yep.
All right.
Fine. So yeah, you're on TV now, Fraser. Sorry.
Oh, that's no problem. It's not like the internet. I mean, it's some startup I've heard about, this television.
Yeah. So it's on Houston Channel 21, and CosmoQuest is on at 10:30 Central Time, Monday through Friday, and Astronomy Cast is on immediately following, and it will be current episodes and back episodes of that.
Awesome. That's really cool.
Yeah. So excited to announce that.
And if people want to find out more about you, where do they go?
Planetary Pan on Twitter and planetary_pan on Instagram. I'm trying to be a bit more active, so come follow me, and I will be sharing science stories that I do for this and CosmoQuest as well.
Michael.
So I am on Twitter at Michael Roderick. I'm also trying to be on there more often. Right now I have photos of my foster dogs if you want to see them. They're pretty cute. And I also do Astronomy on Tap for our State College chapter. So we have our next event coming up on January 25th. We're going to be talking with Milena Rice, grad student at Yale, about Planet 9. And also the authors of We Could Not Fail, Stephen Moss and Richard Paul. So this is a really great story about the first African Americans in the space program. And so we're going to have them on as well. So January 25th. Come check us out online.
Right on. I'll be starting up Open Space again on Monday. I had an interview today with Chris Carr, who is, of course, one of the co-hosts on the Weekly Space Hangout. And we hung around for an hour and talked about his work in galaxy formation and galaxy structure. It was a fascinating conversation. So if you haven't had a chance to check that out, you definitely should. Just a warning to the rest of you, I'm coming for all of you at some point to sequester you and pick your brains over on my YouTube channel at some point. So be prepared. I'm working my way one by one through all of the co-hosts on the Weekly Space Hangout to find out what you're working on. All right. And of course, Universe Today on all the things. If you haven't already, you should sign up to my weekly email newsletter, which I haven't sent out for the last 2 weeks because I didn't really feel like doing anything. So, but I will be definitely sending one out this Friday. Lots of great news to catch up on, and we'll be back in operation. All right, I can put everybody back on the screen. There we go. I know how to do this. Okay, there we go. Thank you, everybody, for watching us today. Thank you, of course, to all of the moderators, especially Nancy Graziano. I hope the new gadget that you were working with worked out well. We've got a new system for Nancy being able to find the comments and questions. I didn't pass along any of the comments and questions because we're not that far into the testing yet, but this was a dry run today, and then on Monday we're going to go full bore on Open Space. So hopefully it'll work a lot better. Save Nancy's carpal tunnel syndrome because she's like copy pasting a lot of questions for me to try and answer. But thank you to my co-hosts for joining, and our special guest, Dr. Alan Stern, who is just like one of the most generous people. I was mentioning this to Alan before, and I didn't get a chance to talk to him about this, but he is one of the most sort of forward-thinking people in the entire space exploration industry, and has been so generous with his time and his outreach across literally decades now. He has been a person that has always been there. If I want to reach out, talk to him, get some information, he's been right there. So
he always answers. He always answers journalists' emails too.
Yeah, he's just terrific. And so if he wants you to join his Twitter and give him a follow over there on Twitter and keep up to date on what he's doing. He's a direct line to the guy who is exploring Pluto. All right, thank you everybody. And coming up next, we've got Astronomy Cast on Friday, I think. We're going to try and do another virtual star party on Saturday, I hope, and then open space again on Monday. So lots of great stuff coming your way almost every day of the week, either here or on everything that CosmoQuest is doing. So hopefully we'll get all of your space needs covered. All right, thanks everybody. And here's to a nice, safe, perfectly boring 2021. Can't wait. See you later.